Hi there, and welcome to Data Analysis with Pandas. So what is Pandas? Pandas is a library built on top of the Python programming language. Now, if you're unfamiliar with Python, it's a language developed by Guido van Rossum in 1991, so it's a little over a quarter century old. And it's really taken off in popularity among the data science community in the last 5 or so years, and that's due in large part to the growth of Pandas. Pandas is just one of tens of thousands of available libraries for Python, and all that a library is a bundle of features and functionalities. They add on new things that you can do with the existing programming language, and each library kind of has its own focus or specialty. Pandas' focus is data analysis, so really it's a tool that you can use for analyzing, filtering, manipulating, aggregating, merging, pivoting, cleaning data. These verbs don't even begin to capture the full scope of everything that you can do, but anytime that you're working with a data set, if you want to tweak it to get it into the shape that you want, or you want to analyze it to get some kind of computations out of it, Pandas is the tool for the job. So if you're familiar with spreadsheet software like Excel or Numbers on a Mac or Google Sheets, Pandas is basically the same thing. It's just built on top of Python, so I like to call it Excel for Python. However, the advantage of Pandas is that it's a lot more powerful. It can work on data sets that have tens of millions of rows, and it can perform calculations on it within milliseconds, which is why I also like to call it Excel on steroids. So there are two sets of prerequisites for this course, required and recommended. As far as the required set on the left, a basic knowledge of spreadsheet software is required. What that means is that you should have played around with Excel at some point before. If you have never played around with spreadsheet software, if you don't know how rows and columns operate, or basic things like sum or average functions, this course will be quite challenging for you to take on. And in addition, a strong basic understanding of data types. By that I mean knowing what a string is, knowing what the difference between an integer number versus a floating point number is, knowing what a Boolean value is, things like that. And if you don't have any experience with these kinds of things, I do recommend starting with Excel. And the reason is because it's going to give you a more visual interface to data sets. Pandas is still visual, but it focuses more on the code. So having that visual interface for you to play around with in Excel is greatly beneficial when you're just starting out and you need to see everything as you make those changes. As far as the recommended set of prerequisites, a strong knowledge of spreadsheet software will go a long way. And by that, I don't mean that you need to know how to code in Excel or know any complex statistical or mathematical functions. All that means is really things like VLOOKUP functions or COUNTIF functions, SUMIF functions. Pivot tables are great. Anytime if you've ever worked with a data set and you've had to mold it or look at it from a different perspective or aggregate it and kind of perform some kind of computations on it, that's really all that's needed, this basic understanding of how you can take a data set and turn it into something a little bit different, look at it from another angle. And in addition, it is recommended to have a basic understanding of Python. Similar to the Excel requirement or the spreadsheet software requirement, this doesn't mean that you have to be a software engineer or that you even have to have built anything in Python. I just mean the rudimentary programming basics like assigning values to variables, defining functions and understanding that they take input and return output, understanding what a list or an array is. Things that are kind of the basics of any programming language. In fact, if you don't know Python but you're familiar with any other programming language, you should be fine as well. Just kind of those simple, high-level, universal concepts that exist in programming languages. And if you have studied Python in the past, but you need a little bit of a refresher, this module concludes with a Python crash course where we'll dive into just the quick review of all of the things we need to know in Python. So if you've covered this before and you just need a quick refresher, we've got that covered in this course. But if you're coming into it with absolutely no knowledge of Python at all and you've never programmed, I do recommend spending an hour or two with that before beginning this course. So about this course, it's split up into several modules, and each focuses on a specific feature in Pandas. Now, Pandas is a colossal library, so there's no way that we can cover every available function and every available tool. So each module focuses on really the most critical components, and they're designed to just kind of get your feet wet and give you a sense of everything that the library can do. There's probably millions of different permutations that you can do to get data into the way that you want it for your project. So my goal is more to give you enough of the tools that you need to get the basics and have the knowledge to pursue the advanced stuff yourself. And in addition, this course is bundled with CSV datasets for us to use. So in order for you to be able to follow along and see the same thing on your screen as I'm seeing on my screen, I would like to use these consistent datasets. I know in other tutorials I've watched on Pandas, the instructors do things like generate random datasets, and I don't like that approach because what the student sees on their screen is completely different from what the instructor sees. So in this course, we'll be using these static CSV datasets, and I'll be telling you which ones to import as we proceed through each lesson. So let's get started. In order to begin working with Pandas, we need to install Python and Pandas. Python is the foundation, so you can't run Pandas without it. And in addition, Pandas exists in an ecosystem of libraries. What I mean by that is that if a data analyst is working with Pandas, it's highly likely that they're working with other Python libraries as well. In fact, it's necessary because Pandas itself is dependent on other Python libraries to run. It has its own foundation of libraries that it uses to build its Pandas functionalities. So we can go and try the brute force method of installing Python and then Pandas and then maybe the 5 or so libraries that we need in addition. But a much easier path for us is installing what's called a distribution. A distribution is just a big bundle of Python, Pandas, and a bunch of different libraries. And the one we're going to install is called the Anaconda distribution by Continuum Analytics. It's entirely free, and it's basically one big installer package that takes together Python, Pandas, and about 100 libraries for data analysis and statistics and mathematics and scientific learning and that kind of stuff. Now, we certainly are not going to need all of those 100 libraries, but it's much easier to just install this one thing than it is to install everything we need one by one separately. So we'll be using the Anaconda distribution. After we install Anaconda, we'll use the computer's terminal or command line to update the libraries that are installed and also install some additional ones. And if you're unfamiliar with terminal or command line or Anaconda or Python or Pandas, don't worry, I'm going to take you through the entire installation process step by step. You're going to see everything along with me on my screen. I'm going to start completely from scratch. So don't worry about that. The setup is covered in this course. A little bit about our development environment, which is called Jupyter Notebook. Now, if you come from a programming background, you may be familiar with working with things like an integrated development environment called an IDE, or a text editor like Sublime or Atom. If you're more familiar with general word processing, you may be coming from, Notepad or TextEdit or Microsoft Word. So there's many different tools that we can use to write code. Throughout these lessons, we'll be using Jupyter Notebook, and it's a little bit different from the typical coding editor. Jupyter Notebook consists of things called cells. You can actually see one on the screen right here in the picture. It's that little box that's in gray that has all the code. And the great thing about the Jupyter Notebook is that we can write our code in these cells, and then we execute them, and right below the cell, the result of our code is output. You can see that little table that appears below. That's the output of the code that's in the gray box above. And this approach really encourages a trial and error approach to solving a problem. You can write code and see how it'll make the results look. If you're dissatisfied, you can keep altering the code until it looks exactly the way that you want. So it's really popular among the data science community for that reason. It doesn't punish the user. It allows the user to recover from mistakes, recover from typos, even have this playful playground mentality of, try one thing even if you don't know it's going to work and very quickly see the results. And there's also other big advantages that we'll dive into in a few moments, but this is just a quick overview of the development environment we'll be using, which is called Jupyter Notebook. All right, a big heads up. We all love pandas, and by that I mean the furry animal, but the library actually has nothing to do with the furry animal. I think it's a bear. Pandas is actually short for Panel Data Structures, which is some kind of complex acronym that's used by economists or statisticians or econometricians. I think I'm pronouncing that correctly. It has nothing to do with the bear, just as a heads up. I don't know why they come up with these funky names, but it's kind of funny, so pandas it is. So I'm going to conclude this lesson by actually doing a quick Google search for a few sample Jupyter Notebooks. And these first two results that pop up, the links to the best IPython and Jupyter Notebooks gallery, as well as a gallery of interesting IPython notebooks on GitHub, are two really great links if you just want to take a look at how a notebook functions or how a notebook might look in real life when we're talking about real data scientists or statisticians that work on these kinds of things. So I'm just going to click on one of these links and show you a sample notebook. I'm going to just pick this one that's called Important Features in Pandas. At this point, you don't have to understand any of the code. What's really more important here is understanding the structure and design of a typical Jupyter notebook and how it operates. By the way, the old deprecated name for a Jupyter notebook is called an IPython notebook. So in case you see those two, just remember that they're interchangeable. They're both the exact same thing. But here you can see these gray cells that we've talked about. We can see here we are using Pandas. And the great thing about a Jupyter notebook is that it combines a lot of different things together. So we have code, but we can also embed things like images or videos or sound effects. We have these headers which allow us to kind of mark our code and talk the person through the process and convert it into sections and give them a better sense of how we're proceeding through the code. So we know that as we move through it, we can see how the person approached the problem. We can see their operations. We can see, oh, at this point, they're worried about the time series operations. All the code below is going to focus on that. In addition to the actual code, and we can see all these outputs, we have regular Python functions in here. We also have things like bar charts and line graphs. Let me scroll down and see if I can find one here. There it is. And these can be directly embedded into the notebook. So when you read it top to bottom, it sort of reads more like a story or more like a book than it does a scientific document, because everything from the code to the commentary to the visuals is all bundled within this single file. So you can see how the person approached the problem, what their methodology was, each step that they took, what they were seeing as they went through it one step at a time. So it really is a very effective environment for teaching and learning. So it's going to be a pretty effective tool for us to use to try out Pandas one step at a time. And that concludes this lesson. So that's just a quick overview of everything that we're going to be doing in this course. In the next lesson, we'll get started with installing the Anaconda distribution. So I'll look forward to seeing you there.